Hello everybody, this is the copper 2 carbonate hydroxide. It's pretty, and the color is due to the copper 2 ion, and there's carbonate and hydroxide, and both the carbonate and the hydroxide will decompose on heat, and both of them turn into an oxide. The carbonate turns into carbon dioxide and oxide, and the two hydroxide ions turn into water and oxide, and it goes to make copper oxide will be the final product. Okay, I'm going to heat it over here with a Bunsen burner. It's properly adjusted. The hottest part of the Bunsen burner is about ½ an inch above the center thing. So I'm going to start heating it. See if you see any evidence of reaction when I start heating the copper carbonate hydroxide. You see any evidence of reaction? Yeah, I see some. You see any? Yep. It's turning black. You see it's turning black? Yeah, it is. Oh, and look, there's getting condensation up here. We said you should make water. It's condensing up there. That's good. You can't see the carbon dioxide because it's a gas. But you can see it's turning black, right? It is turning black. So copper oxide, copper 2 oxide is black. Okay. Now what I'm going to do is let it cool off, and when it cools off I'm going to add some sulfuric acid. The sulfuric acid reacts with oxides to make sulfates. So we should make copper 2 sulfate. That's really copper oxide. We'll let it cool off. Hello everybody again. This is sulfuric acid. This is 6 molar sulfuric acid. It should react with the copper oxide to make copper 2 sulfate, which is a beautiful blue solution. Let's see if that'll happen. So I'll take this off now. It's cool off. Yep. Now I had the 5 milliliters of it. There's 5 milliliters of sulfuric acid, and then put it in here. And then you don't see much happening. We have to heat it up to get it. Oh, it's starting to turn. You see it's starting to turn a little green? I mean a little blue? It is. It's already reacting. So I heat it up, it'll react a little faster. You see the color? Yep, it is getting blue, isn't it? Look at that. Isn't that pretty? And there's still a little bit of copper oxide in there. It's almost all reactive now. Isn't that a pretty color? Yeah, it is. Copper 2 sulfate. It's one of my favorite compounds because it makes a beautiful color. This is our first colorful experiment. There it is. It's almost all gone now. You see that? Hello everybody again. This is the apparatus we're going to use for part 2. We're going to carry out the same reaction we did before, except this is all sealed now. And then what's going to happen as the carbon dioxide comes out, we'll get some water coming out and it'll condense in this one. But carbon dioxide is a gas, and what it's going to do is push water from here over into here. And we measure the amount of water it's pushed over. That'll be equal to the volume of the CO2 it's produced. And then any water is produced will be collected here. And then from the volume of the CO2 you can calculate the mass of the CO2. And then we're going to measure the mass of this after the reaction. The difference in the mass of the copper oxide and the copper carbonate hydroxide will be equal to the mass of the water and the carbon dioxide produced. And once you get the volume of the carbon dioxide, you can compute what its mass is, subtract that from the total mass of the water and carbon dioxide, get the mass of the water. And then we're going to weigh this test tube again, and the difference there will be the mass between that and the empty test tube will be the mass of the copper oxide that is produced. Are we ready to start? You ready? We'll do the same thing, make sure everything's tight. If it's not tight, it won't work. Make sure everything's tight. Okay, so let's get going here. Hey, look, water's running over there. See it? See the water running? It's running into the beaker, so the reaction's starting. And the fact the water's running over there means there's no leaks, I guess. You see the water vapor condensing. I'm going to have to get all the water vapor out of that tube, too, because we don't want to weigh any water in there, in the test tube. Look at that. It's going black again. Same reactions occurring. Let me get some of this water out of here. After the reaction's over, I can just heat the test tube to get the rest of the water out. I think the reaction's it's all black now, isn't it? Yeah, I think the reaction's over. I don't see any more gas coming, any more CO2 being produced. And when I stop this, I'm going to disconnect it here. And put a glass plate over this, because that should have CO2 gas in it. The volume difference is actually, that should have CO2 gas in it. And then I'm going to open this up and let that water run in. Let the water run in there. Okay, that's good. Now, whoops, sorry. Getting a little clumsy here. CO2 is heavier than air anyway. So this is saturated calcium hydroxide solution. They call it lime water because the old name of calcium hydroxide was slaked lime. It's not really lime water, don't drink it. But if that's CO2 in there, then it should precipitate out this way, because you know from the last experiment the calcium carbonate is much more insoluble than calcium hydroxide is. So when I put it in there, the hydroxide ions in here will react with it to make calcium carbonate. Let's see. Now shake it up and see if you get a precipitate in here. See it getting precipitate? You see the precipitate all right? That's a really good chemical test for calcium, for carbon dioxide, because it reacts with calcium hydroxide to make calcium carbonate. And that's calcium carbonate precipitate there. Everybody see that all right? Okay, good. Now what I'm going to do, I'm going to take this test tube and I'm going to take it out a little bit so we can get the water out of there. Need to get the water out of the test tube before we weigh it again. You see the water in there? See it? You can see the water in there. So I'm going to raise this a little bit, and then we're going to heat it to get the water out. We can't weigh it. When we weigh this again, we can't have any water in there. See, we're boiling it off. That's good. It's almost dry. Let's do it a little bit more. Let it cool off a little bit. I don't want to burn myself, do I? Nope. Measure the volume. There's the water that was pushed out by the CO2 gas. The volume of the water there should be equal to the volume of the CO2 produced, because that's what pushed it out. Of course, the CO2 stayed there, but it pushed air out equal to its volume, so that's what happened. So let's see, I will add 50. Let's see. That's a little bit more than 50. Let me pour a little bit back in here. That's 50 right there. And this should be another 50. That's another 50. That's 100. That's 100, right? And then the last should be the last. So there's roughly 150. Okay, so the last one, yeah, the last one is 35.8. 35.8 plus 50 plus 50, right? That's 135, right? 138? Is that what it is?